Hi there. As you saw in lesson 59, a really interesting lesson by the way, you were able to add up the angles of any polygon by dividing the polygon into triangles, and you knew that the interior angles of each triangle are each equal to 180, 180, 180. That meant that a pentagon had 3 times 180 or 180 or 540 degrees, and a decagon had 1, 2, 3, 4, 5, 6 times 180 or 1080 degrees in the interior angles. So neat little method, and including an important formula, S 180 n minus 2. So the total number of degrees was the number of sides minus 2 times 180. So for a pentagon, 5 minus 2 was 3 times 180 or 540. For a decagon, 7 times 180 or 1080, etc. So kind of a neat chapter. Cool application of some basic geometric skills to figure out some formulas that apply to any kind of polygonal shape. Now the next chapter, instead of looking at lesson 60, instead of looking at interior angles, it looks at exterior angles, and finds what I found a very surprising result. First of all, what is the sum of the exterior angles? So they start with a quadrilateral, very comfortable territory, and they define angles 1, 2, 3, and 4. And how do you determine what the sum of those exterior angles is? Well, believe it or not, it's the same as the sum of the interior angles. Why is that? Well, and how do you demonstrate it? Well, you know that angle 1 and angle BAD sum together, and that's the interior and the exterior angle, will sum to 180. Same with angle 2 and angle CBA, that sums to 180. Angle 3 and angle BCD also sums to 180. And angle 4 and angle ADC sum to 180. So you write that out here. Angle 1 BAD, angle 3 BCD, angle 2 plus ABC, and angle 4 plus CDA equals 180. So sum them all together, and you end up with a long equation that sums to 180 plus 180 plus 180 plus 180. But you know that the interior angles, BAD, ABC, CDA, and BCD, all sum to 360. And so therefore, this total of all 8 angles, this sum, minus the sum of the interior angles, which is known, should give you the sum of the exterior angles, the difference, and that is 360. So the 4 exterior angles add up to 360. Okay, exciting, but is that so striking? This is the surprising part, okay? The sum of exterior angles is always 360. How is that possible? Let's just try it out in a couple of cases. Here, the exterior is something, the interior is something. The sum of the 3 interiors will be 180. That's a characteristic of all triangles. And the sum of interior and exterior here will be 180. Interior and exterior here will be 180. 180. So the sum of both, if you were to substitute those values here, you'd have the sum of the exterior is equal to 180 plus 180 plus 180, or 540, minus here you'd have the sum of the interior angles of a triangle would be 180. So 540 minus 180 is magically 360. So you end up with 360 here. And I suppose if you tried it here with a decagon, you'd get the same result, although I won't bother, but that's what they're affirming here, okay? So it turns out that for a polygon with n sides, the interior angles add up to equal the formula you saw in the previous chapter. Second, the total number of angles, both interior and exterior, always add up to 180n. So 180 times the number of sides. And that's logical. 180, 180, 180, the 3 sides. And so the total of exterior angles is a certain number of degrees, x, equals the sum of all angles minus the sum of all the interior angles. So that was the formula you saw in the previous lesson, and that's why I just reminded you of it at the beginning of this one. And here's the math. Just simplify, and x equals 360. So the sum of the exterior angles is always 360. Interesting stuff. interesting exercises to do that will help you develop those notions. Hope you enjoy this lesson as much as I did. Good luck. Bye.